This is on the handout I gave you. This is on matrix multiplication. Let's take a look. Now, like before, in this handout, I have the YouTube sites embedded. So you might want to take a look at this one. This run requires a little bit of time to really master. So don't get discouraged on this one. Don't get overly frustrated. You are at first, have a lot of paper and pencil available. Okay, this takes a while to get. Okay, so the first thing I want you to think about is matrix multiplication is only defined if the number of columns in the first matrix match the number of rows in the second matrix. Remember, we use the letters M and N or NN or P and Q for the number of rows and columns. It's always a number of rows by number of columns. So let's suppose we're going to multiply an M by N matrix together. That means we have M rows and N columns. We're going to do this with an N by P matrix. That means we have N rows and P columns. The result will be an M by P matrix. What's important here is that this N, the number of rows in the second one, match the number of columns in the first one. Just like an M by N with a P by Q. If I take M by N and multiply it with a matrix that has P rows and Q columns, it won't work unless N here, the number of columns in the first matrix, is the same as the number of rows in the second matrix. Okay. Let's take a look at an example. Now, what I want you to think about and I want you to pay attention to is when we're multiplying these matrices together, and I have a few examples here, when we're multiplying them together, we multiply row with column, row with column. I'll repeat that, row with column. So I'm going to multiply the first row right here with the first column here. Okay. So now when I take this first element and I multiply it with the 0, then I'll take the second element in the first row, multiply it with the second element in the second column, and then I'll take the third element in this first row and multiply it with the third element in the first column. I'll multiply those out and add them up. That's going to be the first cell or element in my answer. Next, I have the second column here. What do I do with it? Well, now I'm going to multiply that first row with the second column. So I'm going to take the 1, multiply with the 3. I'm going to take the 4, multiply with the -2. Why the -2? Because they're both second elements in their respective row and column. I'm going to multiply the 4 with the 6. Why the 4 and the 6? Because they're both third elements in their respective matrix, row and column. I add that up. I end up with 23 for that one, 14 for the first. Now, how do I get the second row? So the second row in my answer is going to come from taking the second row, first column. Again, remember, it's row, column, row, column, row, column. So I take the second row, first column, 2 times 0. I take the second element in that second column, or second row rather, and multiply it with the first column, second element. 1 times 1. And then I take the third element in the second row and multiply it with the third element in the first column. 0 times 3. I add that together. We end up with 1. Now to get the second value, this 4 in my answer, we're going to take the second row and multiply it with the second column. You're going to do the same order. So first element in second row, multiply with first element in second column. Second element in second row, multiplied with second element in second column. And third element in second row, multiplied with third element in second column. So that's how we get the 2 times 3, the 1 times -2, and 0 times 6. That adds up to 4. Finally, we have to deal with the third row. So going to go through the same process. The first element in the third row multiplied with the first element in the first column, minus 3 times 0. Second element in third row multiplied with second element in first column, 0 times 1. Third element in third row multiplied with third element in first column, minus 1 times 3. We add it up, we should get minus 3. Then the second element here, this minus 15 in our result, is going to be third row, second column in this case. So we're going to take the first element from the third row, multiply it with the first element from the second column. That's where this minus 3 times 3 comes in. Second element in third row, multiplied with second element in the second column. That's the minus 2 times, or 0 times minus 2. Right. And then finally, minus 1, that third element in the third row times third element in second column. Minus 1 times 6. Add that up, we get minus 15. Let's look at another one. This one's a 3 by 3. Right? It's defined just like the other one, because in this case, the number of columns here, okay, the number of columns here was 3, and the number of rows here was 3. So since we started out with a 3 by 3 and multiplied it with a 3 by 2, okay, columns match rows. So basically we look at the results going to be the number of rows in the first, number of columns in the second. So the result's going to be a 3 by 2. So this is 3 by 3. So we don't have to worry about it not matching up. Same number of rows, same number of columns all the way across. Okay. So how are we going to do it? Same process. We're going to take first row, first column. 1 times 0. Why 1 times 0? First element, first element. Second element in first row times second element in first column. Third element in first row times third element in first column. And that's where these values come from. We add them up, we get 6. We're going to follow that process until we do all the columns here. First row, first element, second column, 1 times 1. Second element second element in first row, second element in second column, 2 times 0. Third element, first row, third element, second column, 4 times minus 2. That adds up to be minus 7. Now we have to continue to fill out that first row. We have to do all the columns here with the first column, for the first row. 1 times 0, 2 times 1. I'm sorry, 2 times 2, sorry. And then 4 times 1. That adds up to be 8. We go through the second row, doing the same process. Second row, first column. 2 times 0. That's where that comes from. 1 times 1. That's where that comes from. 0 times 1. That's where that comes from. Add that up. We get that first element in the second row. That'd be 1. Got to take the second row, second column now. 2 times 1. That's where that comes from. 1 times 0. That's where that comes from. And 0 times minus 2. That's where that comes from. That adds up to be minus 7. Now to finish that first row, for our answer, you got to take first row, third column. 1 times 0. 2 times 2. And 4 times 1. That adds up to be 8. Second row, going to do the same thing. Second row, first column, add up. Second row, second column, add up. Second row, third column, add up. That gives us 1, 2, and 2. So you're going to do the same thing with the third row. So that's the process. Third row, first column, add up. Third row, second column, add up. Third row, third column, add up. What you have to remember to do is you have to remember to multiply out the correct elements. So in other words, when we multiply out, just a reminder, we multiply out this third row. I can multiply first element in the row with first element in each column. I'm going to multiply second element in the row with second element in each column, one at a time. Okay? I multiply third element with third element in the columns, one at a time. So in other words, I don't do that all at once. Just to be clear, I'm going to take the first element times first element. That goes here. Second element times second element in that first column. That goes here. Third element in the first column and third row goes here. First element in second column. Second element in second column. Third element in second column. That's where all that came from, right there. We end up with this matrix. We take a look at 1, 2, 0, minus 2. We're going to multiply with 2, 1, 2, 0, and minus 1, 3. So this is a 2 by 2 times a 3 by 2. That's not defined. Why? Because the number of columns in this first matrix don't match the number of columns in the second matrix. Let's take a look at why that doesn't work. Remember, we multiply to get the first value. We multiply first element in first row with first element in first column. That gives us 2. We multiply second element in first row with second element in first column. That gives us 4. Whoops, we don't have anything to multiply with this minus 1. So we can't ignore it. We can't pretend it doesn't exist. And that's why it's not defined. A second note that A times B isn't always equal to B times A. Unlike ordinary real number multiplication where 3 times 2 is equal to 2 times 3, matrix A times matrix B might not be equal to matrix B times matrix A. When we have a matrix where our main diagonal is all ones, and we have zeros above and zeros below, this is called the identity matrix. We saw the identity matrix when we did the RREF part. The identity matrix is a special matrix where if I multiply something by the identity matrix, I get the value back. So in other words, when I multiply the identity matrix with matrix A, it's going to equal matrix A times the identity matrix, which equals A. So that in matrix land is kind of like multiplying by 1. Okay? 1 times 3, same thing as 3 times 1 is 3. So I times A is the same thing as A times I, which is A. Now, an identity matrix can only be a square matrix. It has to have the same number of rows and columns because the main diagonal here has to be all ones. Now, we did a little bit with the RREF. We're going to do more with solving systems of equations later. I do mention again RREF, and I give you some more videos you might want to look at. However, if you're familiar with this, you probably don't have to spend a lot of time on it. I do want to make sure, though, everybody understands when we get a non-solution, if you will, where it's not all ones in the main diagonal and you have your answers clearly spelled out. We get a non-single solution, a non-unique solution, if you will. When I look at this matrix and I do the RREF, it's a 2 by 4 matrix. And when I go through the process, okay, when I do the RREF, I get this for the first row. So again, what does that mean? That means we have a 1x plus a 0y plus a 113z equals 18/13. Now remember, we slide this 113z over to the other side. Okay. And so we get x equals 113z plus 18/13. And then we do the same thing with the second row. When we isolate the y, we get 513z minus 13. Oops, that should be, sorry about that. We'll fix that before I send it out. This equals z equals any, and this also means z equals any number. So just keep that in mind as we go forward. I hope this helps. Have a good day.